Going around the country, we get a lot of questions from students, and we're going to talk about them today. And they include identification of chemicals, level A choices,
and instrument choices, the ERG, and tons more. So listen in. You know what the worst part about arriving at a hazmat scene is?
Yeah, on a hot day like today, your boots fill up like the goddamn Titanic.
Yes. You know the Titanic's pools are still full?
Yes, they are. And it was a miracle to the lobsters.
But also uncertainty. You have no idea what's in the air.
Yeah, just the whole like, oh, we're going to assume it's a chemical. It doesn't really cut it anymore. You need answers and you need them fast.
And that's where the Explorer comes in. Real-time chemical ID and quantification right in the field.
No more someone scratching their head going, I think it's something bad. It's going to tell you exactly what's there and exactly how much.
Which means you can set up your zones like an adult and not a rookie just guessing where to put the tape.
Yeah, defensive, qualitative data in seconds. So decision-making just became a hell of a lot easier.
Which means no more waiting around for answers. Solid, life-saving intel.
I'm telling you, go check out the Explorer and stop guessing. Go to 908devices.com.
And while we're at it, on a hazmat call, the question is never if radiation matters. It's where you're going to find that.
Oh, yeah. And if it's there, right, half the time it comes to find you first. That's why on all unknowns, rad is one of the first things that we're going to be checking for.
Which is a weird thing because you can't smell it, you can't see it, and if you miss it, you're probably already inside it.
You know, that's the exact reason why teams all over the world are running Teledyne FLIR's defense identifinders. Wow, that was a tongue twister.
But it isn't a one-size-fits-all tool either. They got handheld rids, they got wearable personals, even backpack systems.
All right, so whether you're the first guy walking into the scene or you're sitting there trying to figure out the defense of an entire building, there is something out there that fits the job you have.
And these aren't theoretical tools. These are out there getting used every day by teams that actually rely on radiation data to make decisions.
So go to FLIR Identifinders and search in FLIR, F-L-I-R Identifinders, and find out a little bit more information.
And before we get into this, today's episode is brought to you by Rigaku Analytical Devices, who just launched their 4th generation handheld Raman meter, the Icon X.
So for fast, safe, and accurate chemical analyzation, visit rigakuanalytics.com.
All right, we're back. Another one.
Hey, everybody. We experienced some technical difficulties in between the whatever. Yeah. You guys don't care. You're listening to us. You love to listen to us. Don't fall asleep while driving. We don't recommend that in any way, shape, or form. Hopefully, we can keep you awake. We were saying before in the intro that today we're going to be doing student questions. You know, we travel around the country. We get these random questions that are asked by both inexperienced people and experienced people. The ones that are decent, we write them down, and we're like, you know what? Maybe we should share that with everybody. Or they may not be decent questions, but we get them a lot. And if we get a question more than like 3 or 4 times in a time frame, we write it down and it makes its way to the show. Even crappy questions have a place here, right, Bob?
Yeah, I think so. I think you know what? There's no such thing as a stupid question. There are a ton of stupid questions, but these are pretty good. I think they're definitely, I don't know how many we're going to get through, but there's quite a few, I think.
All right. Well, we'll get through what we can, and then when we're feeling super lazy and don't want to put another show together, we break out this list and we keep going.
Yes, I love it.
Yeah.
All right. So what's the first one?
Let's go. So the first one, right? And I, you know, this is a topic we hit on so much in both chemical and physical properties and metering. I know a bunch of people have come up to you during conferences and asked similarities to these questions. There's variations to it, right? But the question, or the overarching theme of the question is, why do we spend so much time identifying a chemical if the initial actions are often the same?
You know, I was just talking to Tony Perrone this morning about this. And he was saying, you know, sometimes you go and teach, and people get so wrapped around the axle about like silly things like, you know, odor thresholds or, you know, things like that when you're doing your chemical identification. It's like, you know, we said this, don't let perfection be the enemy of good.
Sure.
A lot of times, you know, we spend so much time on the tech ref or setting up pools or tape or cones and stuff like that, and there's people's faces melting off. Like, why are we spending so much time getting, breaking out books and stuff, and there's people dying? We'll be right there. Give us a second.
No, I think it lends to a fundamental problem with the modern age of hazmat. And the modern age of hazmat, and I am not bashing any of the meters that are out there in any way, shape, or form. I think they are absolutely fundamental to run a team, whether you're running a HazCat, whether you're running an FTIR or Raman, anything along those lines. This is not a bash on them, but it has changed our thought process to identifying a chemical versus identifying a hazard. And I think that's where the fundamental problem in this question lies, is that they're literally asking the wrong questions there. I said literally twice. They're asking the wrong questions because their mind frame has been set to this idea that we should be identifying. And they are right. Why do we spend so much time identifying if the initial actions are often the same? The initial actions are often the same because we only have like 9 hazard classes to choose from. So your chances of your initial actions being the same as any of those other initial 9 hazards are going to be 10%, 15%, depending on if you were just to look at the raw, there's, 9 classes and those are the classes, but we know a lot of them are going to be, flammable liquids. Like, we understand that there's different probabilities, but I think that just goes to show how fundamentally off people's thinking is that they're looking at it as identifying instead of finding out the hazard.
Well, in addition to that, I would say that, your initial actions, such as things like put on your gloves, right? And not firefighting gloves. I'm saying, and 90, I don't want to say 95%, a high percentage of times you're going to put on nitrile gloves and you're going to handle the operation with those gloves on. The exception of that is when you can't wear those things, right? Those are the initial actions for a great amount of the operation we go to. We do the same things like put on your SCBA, put on your fire gear, wear nitrile gloves. Those kind of things are done over and over and over. The time we deviate from those things is when something's exceptional. I know that's, I don't know if I'm framing this right, but no, I feel like, oh, we're going to a corrosive. Well, that's not a typical thing. Right. And then we might have to change our gloves to butyl or whatever. Viton.
I like to say, think back to middle school, right? When you were in middle school, 8th grade, we'll throw 8th grade in there. Okay. Any one of your classes, say, had 30 students. Not all those 8th graders acted the same, right? There were all different groups of personalities in there. And while you can be trained in how to teach an 8th grader, right, you have to learn the skills to deal with an individual's personality that comes outside of the personality of those 38th graders. So, you have the class clown, you have the bully, you have the guy who's learning disabled, you have this, you have that. So we identify so that we can learn the minute things about that chemical that makes it special. But overall, you can still deal with 80 to 90% of that chemical or that student based on the fact that they're an 8th grader. And we kind of do the same thing with chemicals, where we're like, yeah, 90% of all the chemicals within this class are going to act the same. But if we can identify, we do, because then we can learn specific characteristics about that chemical. But it's not a requirement.
Yeah, I agree with you. We use it in class all the time. It's like, what do you do difference if it's, diesel, gasoline, jet fuel, kerosene? Nothing. You handle the same thing. Like even corrosives. What if it's a strong acid or a strong base? It's the same. Right. The vast majority of the play is the same. Now the mitigation's different. I'm not going to argue with that, but like there's a significant amount of overlap, and I think a lot of the instructors out there, at least, I don't want to say the instructors are doing this bad. I think a lot of guys, when they come out of class, they're thinking that there's so much complexity to hazmat operations. And there is. I'm not discounting that. But once you do it a lot, you start seeing that there's a consistent pattern that is regularly done, like scuba diving, right? If you're scuba diving, you do the same things over and over and over. But I would do it a little different if I'm in, up, in the Northeast, maybe down in the Caribbean, I do it different. On the West Coast, I do it. But the vast majority of it is like go underwater and swim, breathe,
Right.
like
breathe. It's a key part of scuba diving, breathing. Yeah, without a doubt.
It's kind of important.
Like you mentioned acids and bases before, right? So, we go through all these things. Do we need to know if it's what the exact acid and base is to mitigate them? No, not really. But, there's hydrofluoric acid that's out there. And we kind of want to know that because we want to understand the compatibility with our PPE. So, and that is what? 10% of the knowledge of the run that we need to operate safely. So there is definitely a spot for identifying, but we want to understand the hazard way first.
One other thing, and it's RPDM, recognition primed decision
making directive
memory or something like that, where it's like your hard drives program for things, and you break it down to low risk, high frequency, high risk, and blah blah blah. And the ones that we go to in hazmat, thankfully, are low frequency, high risk, right? And I say thankfully, and you're like, what the hell is this guy talking about? But in that box, it's because it's not frequent. The vast majority of them are we have time to think. And so, like, I'm a big fan. Like, you don't have to have everything memorized. When you're doing your initial actions and you're like, okay, this seems like it's pretty routine, then roll with it. But if anybody on the team goes, my spidey senses are tingling, call pause and do the research. Like, there's nothing saying you can't do the research. But when you're doing a lot, like fuel leaks, we did so many of them that we were like a NASCAR team. We jumped off the rig and it was like everybody
really
did things.
Like the radio never even communicated. Like it just, with the exception of like, hey, what pump are we using? That was it. Right. Once everybody knew what pump we were using, everything just kind of fell into place. You did say something that I want to elaborate on and find out. You said, the vast majority of times we can slow down. What would you recognize as a time or a situation where we couldn't slow down, where we had to act quickly and based on instinct to get a mission done?
I think it's probably going to be a life safety, an imminent or probable life safety issue, whether it's to us or civilians or to people or whatever it is. I think then you're going to have to do a rather quick risk reward analysis.
Yeah.
And, there is no perfect game. I was just listening to Jake's episode. I forgot the guy's name, but he's English, but he's a United States firefighter, and he's doing this whole thing on restructuring the fire service. And, he goes into like, there's no perfect risk versus reward. We do some dangerous gangster shit. That's why you're in this job. So there's going to be danger. You don't work in an office where you can say, realistically, there's not going to be any danger on a normal basis.
Right. And even then, there's incredibly low probability, high risk things that happen in an office building, right? Like the elevator falling, or you tripping down the stairs, or a paper cut that gets infected and you lose your fingers. I don't know. There's risk all around us. We can't ever go to zero.
So... well, let's get to the next one. But first, yes.
Battery fires are starting to change how we think about suppression.
Yeah, because for years it was water, cool it, chase it, and hope it stays out.
Yeah, but now we've got these lithium-ion battery jobs, and it's no longer about just putting the fire out. It's about controlling it, keeping it from propagating, and trying to stop a reignition cycle.
Which is where some of these newer agents are actually making some sense.
And the one that we've been paying the most attention to is TRF Plus from Fire Suppression Solutions. This isn't just kind of it works on everything type of a thing. That's not in any way, shape, or form. It doesn't replace anything that's on your rig. What it is, it's another tool in the toolbox for when the typical things that you would do don't work out.
And when you have something that can be applied early, limit the spread, gives you another option besides just flooding the thing and waiting.
And the options are important, right? Because depending on how your team operates, depends on how you're going to want to apply this. And they have different, solutions for different problems. They've got smaller options for smaller things, and they have these giant bulk kits in case you've got a huge response potential.
So once again, this is not saying this is the answer. This is not saying the problem has changed. And this is one of the tools that may make sense for your playbook.
Go to Fire Suppression Solutions or hit the links in the show note below and do your own research on TRF.
You know what else I love about the city?
All of the gum on the sidewalks that's there for the taking.
Oh, this is great. Like Elf. Just pick it up and start eating it. No, my favorite is the e-scooter gangs.
Oh, yes, because nothing screams hazmat like a moped with a battery that's about to go nuclear.
Which is why Obexian FR is saving the day.
Lightweight, mobile-friendly, designed for first responders because the last thing we need is extra weight when things start to heat up.
And it's third-party tested to lower toxic gases below the ideal H levels.
So it gives you an extra added layer of protection while you're putting out that scooter fire to your lungs.
And if you need more, don't worry, fam. Obexian FR comes with a pallet or the certified poly drums.
Which is great when you're going, holy crap, we're going to need a lot of this.
So protect your team and your lungs. Go to thehazmatguys.dgeo.com. That's thehazmatguys.dgeo.com. Yeah. Another question.
Yes. What's the biggest mistake responders make with atmospheric meters?
I know a lot of people are going to say something technical about knowing your meter. I think it's I'm going to say my biggest thing is the actual technique, the physical manipulation of the meter in the space in an XYZ atmosphere, environment.
That is a very technical answer. So elaborate.
All right. So, when we say that you should be measuring high, middle, and low, I think the worst one is when people go, oh, it's low, no problem, and they're measuring around their knee, right? And now you have a gas. I'm just going to throw out a name, butane, right? Butane is super flat. So if you're not literally touching the ground with that probe, if you're like 3 inches off the ground, you're probably going to get like 1, 2, 3, 5%, something like that. But if you're touching the ground, it's 100%. And I think people, of all the chemicals that are in the world, the vast, vast, vast majority go down. Right? So if you're measuring your knee, is it possible you have a gas below your knee?
Yeah, absolutely.
It's probable.
My propane incident, checks that box 100%.
Yeah.
Biggest mistake that I see, I feel like now this is, so the question is specific to responders. That's how we worded this. Sometimes it's technicians, sometimes it's operations. So remember, we're getting these are just overarching questions that we get a lot. When I look at first responders in general, the biggest atmospheric metering mistake that they make is thinking that their meter is actually giving them a lot of information, right? Where they walk in and they've got a 4-gas. This is specific to more to operations. Technicians have a little bit better understanding. But operations level people, they walk in with their 4-gas. Now, 4-gas meters, it will meter for oxygen, carbon dioxide, hydrogen sulfide, CO. If you're a 5-gas, you've got PID thrown in there, right? So when you look at what that meter can actually pick up versus what is actually could be in the atmosphere, you really quickly realize that meter is really, really limited in telling you that the atmosphere is safe. It's really just being like, hey, an LEL, right? So, hey, there's no explosive limit and you've got good oxygen. There's no CO and there's no H2S. Beyond that, we don't have a freaking clue what's happening inside of this, and people will walk in and be like, oh, it's safe because my meter tells me it's safe, yet there's millions of chemicals out there that could be in the atmosphere that people don't recognize as potentially being there because they just think, well, if there's something in the air, my meter is going to pick it up. And I think that's one of the biggest mistakes that first responders make from an operations point of view.
All right, you couple that with putting the meter in the wrong physical location, and now you've just handicapped that limited amount of detection ability. And I will say, the 4-gas meter, statistically speaking, handles our main concerns.
Yes.
Like for a regular cop, a regular fireman that's walking into an emergency of some sort, that meter will scratch your itch for the vast majority of them. When you're in technician land and you're starting to go to things that are out of the norm, like not a natural gas leak, not a CO, emergency, not a one of those type things where you start to get into outliers, then this becomes exacerbated, because if the guy walks in and every single time you see like lieutenant or fireman, whatever it is, and they're holding the meter, they're holding it in a position of comfort to read it. Right. And they're not really moving it vertically or horizontally, or they're just, I hate to say it this way, but lazy. Right. They're just physically lazy to say, oh, I got to put this thing on the ground, put a string on it and literally put it on the ground and let it do its thing down there. You don't have to hold it on the ground.
We've all been there, right? I mean, for us, we threw all of our meters into a bag and walked in like a contractor walking in to go do a plumbing job with all of our tools in the bag, and we would just kind of walk around with it. And in order to go high, medium, low, we'd literally have to take everything out of the bag and individually bring it down to the ground. And sometimes you get complacent. Sometimes you just don't realize that the danger exists to even start to do that. But yeah, I would definitely agree with you. The position is a big one.
I think so. All right. You want to kill it here and then come back?
Yeah, we could do that.
All right. Come back for the next couple of questions. A little sluggish.